It's come to my attention that we haven't discussed the antiderivative of a to the x. Now, we know e to the x. We love it. The antiderivative of e to the x is just e to the x plus c. But we haven't really taken the time to officially talk about the antiderivative of a to the x. So let's derive that formula here, and when we're done, we'll just put a box around it, and you can use that formula each time. The trick is to convert this a to the x. So when I say a to the x, a is some other number besides e, like 2 to the x, or 7 to the x, or 10 to the x. But what we're going to do is we're going to convert it to an e to the u. And the way we do that is we just insert, using a little trick from algebra, we insert an e, I'll put the e in red, as the new base. And then the new exponent would be the natural log, oops, that's not natural log, the natural log of a to the x. So in case you've forgotten, oops, and let me stick my dx on here. E raised to some power and natural log, those are inverse functions. So they undo each other. And so this expression here, which I'll circle in green, this is equivalent to a to the x. But it's written in a way that now we can deal with. It's a composition now, right? The exponent is this natural log of a to the x. In fact, let's rewrite that before we do our calculus here. Let's just do a little bit more algebra here, and we'll write this as e to the x natural log of a. Gosh, I keep doing my natural logs wrong. Right, so I just use my properties of logarithms to bring the x out in front. And then what we can do here is a little u substitution to figure out this antiderivative. So I'll make u equal x natural log of a. Natural log of a is just a constant, so the derivative is just natural log of a. You know, like the derivative of 7x is 7. The derivative of x times natural log of a is just natural log of a. And that means that dx will be replaced with du over natural log of a. And then when we write our new indefinite integral, and sorry, I'm heading up this way now. A little disorganized on the chart here because it's early in the morning. But our new integral will be e to the u du over natural log of a. And then since natural log of a is a constant, I'm going to factor that out to the front using my constant multiple rule. And so the, oops, I wrote 1/2. It's not 1/2, it's 1 over log a. It is a fraction, it's just not that fraction. 1 over natural log of a. And then we have e to the u, and I screwed that up too. Okay, so let's do a e to the u du. And remember, we love e to the u, right? So this antiderivative is just 1 over natural log of a times e to the u plus c. Now, we didn't start out with e to the u. We started out with a to the x. So what I'm going to do is work my way backwards. Remember, we said u was x log a. So we'll rewrite that. 1 over natural log of a, e to the x natural log of a plus c. And then remember, this guy is just a to the x. So my final, and I'm going to squeeze it in here at the bottom here, my final antiderivative for a to the x is a to the x times 1 over natural log of a, and I'll just put the natural log of a right here, and then plus c. And that is the formula that we're going to use whenever you have to do an antiderivative of some exponential function that doesn't have a base e. Just remember that when you're done, you have to multiply by 1 over natural log of a. So it's still a to the x, but there's an extra factor in there. Let me give you a quick example on the next screen, and we'll be done with this bad boy. So here's an indefinite integral. It's x times 2 raised to the 4x squared. And following our usual plan, we are going to pick the exponent for our u substitution so that we can transform this because it's a composition. So my exponent is 4x squared. My derivative is 8x. And that means dx will be replaced with du over 8x. When I write my new indefinite integral then, I'll have x times 2 to the u, and then du over 8x. Okay, and notice the x's are going to cancel, which is great news, and I'm left with a 1/8 for a factor. I will put that 1/8 out in front, and now I just have 2 to the u du. Now, we just talked about how we handle 2 to the u. All that's going to be, and I'm going to write this antiderivative here in red, the antiderivative for 2 to the u is 1 over natural log of 2 times 2 to the u. And then don't forget your plus c. And then we also can't forget this 1/8, so we have to multiply by 1/8 as well. And then remember that u was 4x squared. So when we write our final antiderivative here, I'm going to write this as 1 over 8 log 2 times 2 to the 4x squared plus c. And that guy is the antiderivative. And the whole point of this example was to show you that you could deal with this 2 to the u, right? It's just 2 to the u. Oops, I dropped my pen there. It's just 2 to the u, but you got to multiply by 1 over log 2. So very similar to an e to the x, but there's an extra factor there. Okay, so that's my, as brief as I can make it, little introduction to the antiderivatives of a to the x. Good luck with these problems, and if you run into any issues, you know where to find me. In the meantime, take care.